These two proofs we'll do today, then we'll do the last one tomorrow. Now I've just drawn up some instructions here on how to do this one, but I'm not going to go through that with you. I'll put a solution up after, I'll give you an opportunity to have a go at it. Some of us were able to crack it last week. But I do want to go through this one, because this is quite a challenging proof to do. Alright, so I'm going to go through this with you. So let's have a look up here, we'll go through this, and then I'll stop, you can have a go at that, and then it's that mixed revision, you can work on your folio, you can catch up with stuff you've missed, and I'll float around and find out what everyone's up to. So this is what we're trying to prove, that xt squared is equal to xa times by xb. And the way we're going to do this is we're going to prove first that triangle, we're going to call it a triangle xat is similar to triangle xbt. Okay, so firstly, so we're looking at that big triangle and then this little triangle here. Alright, so firstly, this angle's in common. Alright, so angle AXP is common. And then let's let angle TBA equal alpha. So if this is alpha, alright, then this angle here is also alpha. Alright, and what's the theorem for that? ATX is alpha. Right. Yeah, that's a quick squeeze, I can't remember my name off the top of my head.
Chord line. Chord.
Tangent chord. Alright, so yeah, so like if you ignore this part, you've seen that before. That angle and that angle are the same. We've proved that theorem already. And so we've got two angles that are in common, so we've got similar triangles. Okay? As soon as we have this angle's in common, this angle's the same, so we've got two angles that are the same, therefore the angles are similar, the triangles are similar. Triangle XAT is similar to triangle XBT. And then we're going to make an argument based on the sides being in ratio again. So what I'm going to do here is I'm going to abstract both of these triangles because it's a little bit difficult to make this argument just by looking at it. So the first triangle we've got is this one, AXT. So here we've got AXT, and we've got theta, and we've got alpha. And then I'm going to draw the other triangle, which is like this. And we've got X, T, and B, where this is alpha, and this is theta. And so if we think of what sides are corresponding, XB is corresponding with XT. Alright, we can see that because this is the side that joins these two angles in this triangle. This is probably the trickiest part about this proof, so just have a look up here. These triangles are similar, we've established that because they've got the same internal angles. XB corresponds with XT because they're connecting the same angles. Alright. And then you can have XA corresponds with XT, corresponds with XA,
The other way.
corresponds with XTX. Oh, sorry, I'm talking about AT, where this is the one, AX is what we're interested in, that's correct. AX, okay, this one here, it's going off theta, that's how we should think about it. We've established that one. AX is going off theta. Here the angle's theta as well, so that's going to correspond with this side. We know it can't be this one because this one already corresponds with XT. Okay? If you want, you can put a third angle in there, it could be anything. Beta, and then the argument becomes like even clearer. Okay, so XA connects theta and beta. Here is theta and beta, so they're connected. So these sides correspond. Okay, so now let's make the argument. Our argument is going to be XT, so let's make it for this one, divided by, which side corresponds with it? XA, okay, remember we have to have the corresponding side, XT divided by XA is equal to XB divided by what corresponds with XB? XT. And then if we cross multiply here, we've got XT squared is equal to XA times XB. So that is quite a tricky one to pull out that abstraction there. You saw me stumbling a bit here, trying to rotate those triangles in my head. All right, so maybe put the third angle in and we can see pretty clearly what sides correspond with one another. Okay, so have a go at this one, and then I'll put the proof up there for that in a moment, and then we'll do the next one on Wednesday.